Aloha, I'm Anna Marcia Lacayo with PTC. Please join me in welcoming panelists Gus Anderson, David Baer, Mike King, and moderator Nathan White of Peraton in this morning's session on the current state of SATCOM commercialization and the role of an end-to-end service provider.
Aloha and welcome to PTC's panel on the current state of SATCOM commercialization and the role of the end-to-end service provider. I'm Nate White, VP and General Manager for Peraton Government Communications, the moderator for this panel. The global pandemic has certainly changed the PTC experience this year. Normally, we'd be in the great weather in Honolulu, yet most of us here are on the US mainland dealing with the snow and cold temperatures. As a matter of fact, just yesterday we had snow, and today it's 36 degrees Fahrenheit, which is in the low single digits Celsius. We have a great panel from across the industry that includes government system integrators, satellite fleet owner operators, and satellite ground state solution providers. Our panelists today include Mike King, Chief Growth Officer, Peraton Incorporated in the US, Mr. David Baer, President and CEO of Eutelsat America Corp in the US, Mr. Gus Anderson, Senior Director, Business Development, Global Enterprise Solutions, Leonardo DRS, and Mr. Rick Sanford, Vice President, Strategic Business Development, Emergent Technologies Incorporated, also in the US. Each panelist will give some introductory remarks, and then we'll go through a series of questions and answers. Among a range of integrated and developed solutions, Peraton provides communication services to the US and Canadian government agencies, as well as commercial critical infrastructure providers. Across our customer base, we are seeing increased demand for more commercial SATCOM services. These customers want more competitive pricing, bandwidth flexibility, simplicity of operation, and access to a range of satellite fleets delivered end-to-end by a single managed service provider. This is a similar challenge faced by the remote Pacific Island nations. Our panelists will discuss what they are seeing with their customers and solutions that can meet this market space and this market shift. I'll now hand over to Mike King for his introductory remarks. Mike?
Thanks, Nate. I appreciate it, and aloha. You already provided a brief introduction of Peraton and our view on the need for more commercial managed SATCOM services. But let me add a little context to why this is important for us and our customers. Peraton has operations scattered throughout the world, supporting our customers' global missions. That includes personnel in 10 different time zones and latitudes, spanning from the Arctic Circle, about 950 miles from the North Pole, to Antarctica. As just one example, we support all mission communications for NASA, operating 70-meter satellite dishes on 3 continents in support of deep space communications, flying satellites and managing the ground stations for communications to the International Space Station, and operating the Near-Earth network, where we utilize both NASA-owned and commercial stations around the world to service national and international government and commercial entities with satellites in LEO, GEO, and lunar orbit with multiple frequency bands. We support these programs with dedicated expert technicians and engineers. Programs are complex and require that type of support. However, there's an entire other area of customers that we serve that have a growing interest in leveraging commercial satellite services and communications to augment, replace, or provide resiliency for government missions. Although the government uses some commercial services today, like NASA's use of the commercial Earth terminals for its near-Earth network, government customers are investigating fully integrated managed services that have the potential to provide lower costs and easier use. Many government customers operate in remote areas with virtually no access to wireless or wired communications. Satellite, in that regard, is the best communication solution for the end users in those areas. Often, these end users only have a rudimentary understanding of how to operate SATCOM terminals. As a result, we see customers that have various challenges effectively completing the comm link with the satellite. And sometimes they even generate interference that impacts other users of the satellite. And we can't forget that the cost to train operators and deploy different SATCOM terminals to a remote area only adds to the total life cycle costs of that capability. The challenges faced by our remote customers are like those faced by the Pacific Island nations, particularly those that are economically disadvantaged and remote from wired communication solutions. Governments have the same high cost, low data rate challenges in the Asia Pacific region. This provides a common problem for industry to address with smaller nations where they can benefit from civilian and spending of nations with larger economies. Several recent technology innovations and new business models are enabling better satellite access at lower cost. A few of these include the rapid growth in LEO commercial SATCOM providers, the advent of the first software-defined satellites, progress in the development of electronically steered array, or ESA antennas and smart electronics, and the emergence of providers that are delivering end-to-end managed SATCOM services. The current race for commercial LEO SATCOM services promises high bandwidth, low latency communications over much of the globe at a low cost, including inexpensive and easy to operate user terminals. But this is very hard, and the market is still really in its infancy and in the early stages. Where we're at now with LEO SATCOM services reminds me of 15 years ago when I was building a combination of wired, microwave, and cellular networks in rural areas of the US, hoping to reduce the digital divide between rural and populated areas. In some ways, that challenge still exists today, but the advancements made in closing that gap have been substantial. Along the way, that market went through multiple generations and swap out of technologies, and there were also significant changes and consolidations in the leading companies. The commercial LEO SATCOM market of today has many of those same traits. Nevertheless, market advances are continuing to occur. We're starting to see SATCOM services at monthly prices near those of terrestrial broadband services. However, there will be coverage gaps, and they will remain until LEO SATCOM providers' ambitious and technically challenging constellations are completed. And while most of the LEO providers are focusing most of their coverage in regions with the densest consumer populations, once the cost of launching and maintaining those constellations are recovered, more remote locations will undoubtedly benefit from LEO SATCOM services. Along with new commercial LEO providers, software-defined satellites are providing flexibility and adaptability for a new generation of satellites. Having virtual onboard electronics enables radios and other electronics to be upgraded and redefined over the life of the satellite, rather than being limited by the hardware that was delivered at launch. This means satellites over a 20-year lifespan can keep up with the technology changes rather than being completely bound by the decades-old technologies. We have seen the benefits of software-defined networks for terrestrial communications, and it's exciting to see how software-defined satellites will advance the capabilities for ubiquitous communications and other satellite-delivered capabilities. Today, many user terminals require an understanding of SATCOM mechanics, and it's an involved setup process of pointing, alignment, polarization, and power adjustment to get it right. This can be difficult for geoterminals and frankly, completely daunting for the tracking antennas required for LEO and MEO connectivity. Errors in setup can adversely impact the data rate and at worst cause catastrophic interference for other users on the same or adjacent satellites. The new electronically steered array user terminals and smart electronics begin to abstract the complexity of SATCOM terminal operations from the end users and from the operators. ESA terminals are making it easier for users to connect with a few different satellite providers, but still require the buyer to put together the total solution of terminal, bandwidth, and backhaul. This opens the opportunity for a service provider to efficiently manage services for many disparate users with one set of satellite resources. Since most satellite fleet operators and owners primarily focus on their own satellite fleets and Earth terminal gateways, we believe there's an additional market need for managed service integrators to provide end consumers and government customers with a complete and tailorable service. Think of it as kind of a MVNO for SATCOM, a service that provides end-to-end communications, continuous performance management, anytime, anywhere the customer needs those services. The flexibility to access different spectrum across multiple constellations, commercial and government owned, with easy to use terminals and multiple network access are requirements Peraton is addressing with its government customers. Being an effective SATCOM managed service provider requires understanding of the customer's mission, strong partnerships with other providers that facilitate the end-to-end service chain, and a platform that can handle the speed, scale, and continual awareness of operations, staying abreast of evolving technology drivers, and even doing things as simple as just managing the payment chain associated with those programs. I'll close by saying many commercial and government SATCOM customers are starting to see technologies and services that are driving larger coverage areas, easier to use services, and lower costs. As the market develops more managed services, consumers and government users will benefit from an overall better customer experience using SATCOM anywhere, anytime. Thanks, Nate. And with that, I'll turn it back.
Thanks, Mike. Those great comments. Dave, I'll turn it over to you now.
Mahalo, Nate, and aloha to everybody participating in the conference this year, albeit virtually. As mentioned before, I think it'd be a lot more fun for most of us to be attending in person, which I have in the past, but we'll forego that and hope for 2022 and make everything work there. Just a little bit of background on myself. I've been in the satellite industry for 30 plus years now, and most recently as the CEO of Eutelsat America Corp, which is the fully owned subsidiary of Eutelsat based in Paris. We do primarily government work, but do some commercial work as well. And actually we support a lot of the other people on this panel. I'm apparently the only satellite operator, fleet operator. So some of our systems are used to support a lot of the things going on. As you may know, Eutelsat has 39 geosynchronous satellites, and we're, I guess, one of the oldest satellite operators and provide satellite services now around the world. Eutelsat America Corp, as I said, we're based in Washington, and we support mostly government contracts. And we have more bandwidth under capacity right now for the US government than just about anybody else, almost 5 gigahertz worth of capacity. So, and we do have a presence around the world, as I said. Wish we had more in the Pacific, but we have several significant satellites that provide a lot of aeromobile connectivity and some wide area connectivity out there as well at the 172 and 174 degree locations, as well as a satellite at 70 degrees east that spans from Eastern or Western Asia all the way back to Europe. So that's a significant satellite for a number of operators, primarily on the government side, but just about everybody else uses them as well. Traditionally, Eutelsat has not been a service industry or a service company. They provided bandwidth and capacity originally for the television markets in Europe and the Middle East. More recently, they've branched out with acquisitions to have satellites around the world, including the Pacific, and have also recently branched out to provide some of the services that were described in the earlier comments. A lot of us had attended the SIA DoD workshop that was held again virtually, but out of Washington back in December. A lot of the comments and a lot of the demands and a lot of the requests from the government were for bandwidth as a service, or just services. They don't want to touch the infrastructure. They want to have the services. And we assume the same is true for a lot of commercial entities as well, especially in the Pacific, because of diversity of locations and all kinds of other reasons to support those types of things. So Eutelsat has only recently moved into the services industry with an attempt back almost 10 years ago now with the KA-SAT broadband service, which provided was the first satellite operator to provide broadband services through KA frequencies into Europe and the Middle East. That has now grown over the last 10 years, and we've recently launched a VHTS satellite, or a high throughput satellite, over Africa, and another one is coming up this year. But again, that's about the only services per se that Eutelsat's been working in over the past 5 to 10 years. We hope to expand that, again, primarily at the request of the US government, and we see where the markets are going. There are a lot of other options out there for bandwidth, whether it's low Earth or GEO or terrestrial. And the need to have a common solution to support users who just want a service is growing by the day. One of the latest satellites we have that does address some of this is one of the software-defined satellites that was mentioned previously. It's called Quantum and will be launched in 2021. It is, again, truly a software-defined satellite, and the first one we know of on the commercial side that will be able to reconfigure its beams and supply capacity on demand in locations throughout the visual arc of the satellite. The bad news is that one's going to be located over Africa and the Middle East for the first one, but we do hope to have additional satellites launched in the coming years that would equally well support operations in the Pacific. With that, I would like to show a brief video on Quantum, and after that, I'll turn it back over to Nate. So I'll try and do a screen share here and get that one running. And Nate, back to you.
Thanks, Dave. That was a great video illustrating how Quantum operates and the features. It does a lot better than some of the briefings I've read, so I appreciate it. With that, we'll turn it over to Gus.
Well, thank you, everybody. Do a quick screen share here. Get my slides going. Let me know if you can all see that. We good on slides?
Yeah.
Great. So thanks for the video, Dave. Super video. And as Dave mentioned, some of the people on this call represent companies that do business with Eutelsat, and Leonardo DRS is one of those. And also, I'm very happy to be on the panel with a fellow integrator company, Peraton, another great integrator in the market. My remarks may sound a little bit like Mike King's because of that, but I like our slide deck because I think it pictorially shows folks what it is integrators do for a living. So with that, let me kick it off by saying I'm Gus Anderson, Senior Business Development Manager for Leonardo DRS in the commercial satellite communications space. Leonardo DRS is a leading ComSat integrator, so I want to give you today a perspective on the commercial integrator's role in providing end-to-end services. First, let me describe what I mean by a ComSatcom integrator. There are generally three characteristics that define a true integrator. First, they do not own their own fleet of satellites. This is critical because it allows the integrator to be agnostic when trying to bring the best solution to the customer. Agnostic as to which satellites to use, agnostic as to equipment, especially modems and terminals, and agnostic as to the terrestrial backhaul used to support the network, especially teleports and gateways. Second, integrators are equipped for and practiced at providing true and full end-to-end solutions, from bandwidth provisioning to terminal modem selection to engineering and, of course, security, critical in this day and age of cyber threats. And lastly, fully capable integrators are already operating global networks for which they are both owner and operator. DRS calls its collection of global networks our information and communications technology ecosystem, or ecosystem for short. And so over the next few minutes, I'm going to give you a peek into the Leonardo DRS ecosystem, which really is nothing more than a model for the integrator's end-to-end service offering. So in this slide, you see at the top level of our ecosystem, the GEO and MEO satellite bandwidth services currently on the market today. As is the case with DRS, integrators have long-standing relationships with all the major fleet owners and most of the mid-tier and small owners. These relationships, both formal as part of master services agreements and informal in terms of the personal connections between the respective companies, these are key to integrators being able to provide capabilities that meet customer requirements. And one of those new technologies to which DRS as an integrator is especially attuned are LEO satellites. And Mike was talking about these as well. Note that I include the LEO satellite constellations as part of the DRS ecosystem. LEO's promise of gigabits per second throughput, low latency, polar coverages, just to name a few examples, these will all be welcome additions to the DRS ecosystem and a terrific new capability that all integrators will be able to offer. A final point on LEO, there's a lot of excitement surrounding LEO, as there should be, but let's be clear, LEO advancements will be a complement to any integrator's ecosystem. LEO allows integrators to offer the additional capabilities for numerous customer requirements, but LEO will not replace the GEO MEO fleets, nor will LEO replace terrestrial. In this slide, you see the terrestrial design that will directly service the customer. You see this directly below the satellite fleets. This represents DRS's terrestrial network that connects a myriad of satellites with Earth and ultimately the users. The type of network in terms of size, reach, capability, and security that all integrators aspire to own and to operate. In this slide here, you see the management level of the terrestrial network. At the center of network operations is operations and security, of course. Integrator global network operation and security centers like DRS's provide persistent monitoring and control, provide tier 1, 2, and 3 help desk services, and most, I think, exceptionally provide streamlined trouble ticket systems for customers. Integrator ticketing systems are extremely valued because of their holistic view of the network. Integrator NOS technicians have the ability to see the entire network, satellite bandwidth, terrestrial routes, hub equipment, security devices, potentially even software applications and endpoints. So their tickets reflect this complete network view and give customers a single point of contact for all issues on the network. And this slide here shows the information technology services and applications that serve the customers. Some of these services are not managed by the integrators. In fact, most may not be. Rather, the integrator provides and secures the path so the customer can offer the services to their users. For example, our slide shows DISN services, or DISN, which are the US military email, intranet, and VTC capabilities. DRS does not manage these services, but we have customers that use our ecosystem to provide these services to US military customers. In this slide, we depict perhaps as the most important part of any telecommunications ecosystem, the customer's interface with and access to the network. The customers are represented by various forms of user interface within the ecosystem: satellite terminals, fiber or cable connections, mobile device connections. These represent customers accessing the information and communications technology solutions designed, engineered, created, and offered by the integrators. This is one of the key strengths of the integrators. We have the ability to connect customers and users with almost any technology solution. Integrators connect customers on land, air, and sea. Integrators connect both mobile users and static sites. And large integrators like DRS and Peraton, with a fully developed ecosystem, can support any customer requirement set from military command, any customer requirement set from military command and control to telemedicine to geospatial data transfer. On the right side of this next slide, hopefully you can see it, is an overlay titled Customer Portal. The ICT portal is something that DRS as an integrator offers all its customers. The ICT portal offers a consolidated view of management and operations so the customer can see in near real time how the network and the personnel managing the network are performing. Portals are designed around each customer's needs, but can include views into the trouble ticket status, network status down to the end user device, performance metrics, status of projects or upgrades, and even status of personnel critical to managing the network. Integrated portals can also provide visibility into cost accounting, assuring a program operates within budget. And DRS customer portals are also secured to customer cyber and security standards. Again, on the right side, we see another overlay titled Cybersecurity. It's important to note that COM/SATCOM integrators can bring the same levels of security as can be provided on government networks. And commercial networks can be accredited to operate to these government standards. For example, DRS applies a cybersecurity framework and methodology across our network that is accredited to risk management framework security standards as established by the US federal government and the Department of Defense. DRS's network solution is currently operating under government-issued authority to operate and authority to communicate of risk management, moderate, high. Very proud of that. So, I think I bumped ahead on my slides. There we go. So this is the last and perhaps the most important slide. There's a lot of talk and written material that's circulating both within government and industry around phrases like end-to-end service, managed service, and most recently SATCOM-as-a-service. Now, I'm not saying DRS has the final word on the meanings of all these phrases, but here's our current interpretation. And we think it's kind of useful in helping to frame everyone's understanding of what these things mean. We see end-to-end as merely a general descriptor or category of satellite service. And within that category of end-to-end, you have two basic integrator models for complex SATCOM solutions. One is managed service, and the other is SATCOM-as-a-service, and we do not believe these are the same thing. I've listed some basic characteristics on this slide, but I'll sum them up as follows. Managed services are generally purpose-built to meet specific customer requirements, while SATCOM-as-a-service networks are built to meet some more general market demand. DRS is not a proponent of SATCOM-as-a-service for the US government, not because we cannot offer it. In fact, our ecosystem makes us uniquely poised to provide satellite as a service. We are not a proponent because our customers cannot compromise on their requirements, because they generally want some level of control and visibility into the enterprise, and because they want a significant amount of flexibility, reliability, and resilience. And managed services provide those characteristics. They also know, and we often show them, that a managed service over time will generally give you better service at lower cost than SATCOM-as-a-service. All right, I'm almost wrapped up. Last slide. That's my contact information. If anyone wants to reach out to me, I can put you in touch with our top experts in satellite communications, terrestrial communications, cyber, and all other things integrator. Thank you so much, and back to you, Nate.
Thanks, Gus. I appreciate it. So in the interim, I did get a note from Rick. He's not going to be able to make the panel, so we'll adapt with some questions. I was taking notes here along the way to potentially ask some other questions. So the first question, what new SATCOM technologies are being deployed that support management of multiple customers within a beam's footprint? And since Dave talked about quantum, we'll lead off with him to maybe go into more detail about quantum, or we see some other capabilities that are emerging that might help in that arena.
Thanks, Nate. Yeah, the quantum satellite does provide a lot of opportunity to manage multiple users in a single beam. And one of the features that I did not talk about previously was a system called CMRS, which basically allows the operator, whether it's an integrator or an operator on the ground, to command the satellite directly, which is, again, another unique feature. What that allows the end user or customer to do is to split beams, allocate power, change frequencies within a certain set of limitations, any way they want, any time they want. So they can manage the systems for different allocations of bandwidth or throughput as it changes during a day, or during a mission, or during any kind of natural disaster, things like that, that they can allocate power to. And this is unique. It basically allows you with a computer screen or a laptop to basically tap into the command and control system of the satellite, or at least the communications part of the satellite, to do that allocation of beams and frequencies. You can add more power to one region, take it away from another region. In the case of government operations, where there are potential interference or jamming situations, you can actually shape beams potentially around where the jamming source is if it doesn't affect things. But that's the kind of things that Eutelsat is putting out there right now. Again, we don't do services per se for the most part, but quantum now allows the end user or integrator to do those services on the fly at any time. So that's one of the technologies I'd say that was out there, at least on the satellite side of things. The other guys can probably talk a little bit more to it on management systems on the ground.
Okay, thanks, Dave. Gus or Mike, did you guys want to add anything else?
Sure, I'll go ahead and jump in. Or Mike, you want to go first? I see you unmuted yourself there.
No, go ahead, Gus.
So first of all, I want to say that the DRS has been in long conversations with Eutelsat about their quantum offering. We think it's just a fantastic technology. There's another company recently, Optus, put out a press release. They're looking at launching a software-defined satellite, so in the near future. So these are really, I think, important developments. You know, on the ground, the new EMC platforms, a lot of them being put out, Kratos and Hughes, I think most notably, these are all taking into account the potential management of a single user under or multiple users within a single beam. I mean, I'd also like to point out that, you know, that might not be the only solution. You can look at, you know, multiple small beams inside of a defined area, which I think LEO is going to provide a lot of relief in that area. You're going to, with the, I think right now, SpaceX, OneWeb, back in business, maybe even Telesat. We like Telesat because of their strong government backing, and also because they are truly going to be an agnostic provider. They want you to be able to bring your own device to the network. Hopefully you can find an ESA to do that, but that's kind of what they want you to do.
No problem.
You know, we think that there's a lot of capability that you're going to get from having these small beams within tight areas, and O3B also another offering in that regard. So Mike, over to you.
Thanks, I appreciate that. And before this, let me just say that I thought your charts were great. Did a really good job of explaining the role and showcasing what integrators bring to the environment. And David, you know, as I talked about software-defined satellites and what that can bring to the marketplace, again, a great video of what quantum can do. We've obviously had lots of discussions over the years on quantum. with your organization, and really, really impressed with what that satellite is going to deliver in the marketplace. And you are correct. Yeah, we'll talk more about it from the Peraton perspective, from a ground side of it. And for us, it's about implementing kind of software-defined ground platforms that can leverage these new satellites and ground technologies that can be delivered. You know, it allows us to deliver multi-tenant environments for a range of government and commercial critical infrastructure customers, giving access to a variety of different ground terminals and satellite options globally without requiring them to self-integrate the services, is how we see this moving forward.
All right, thanks, guys. Let's find another question here. Let's see. Let's go with, what are the challenges to doing this cost effectively in the Asia Pac region? I'll turn this back over to Dave, because I know you guys have looked at that, and I don't. System integrator guys could probably weigh in a little bit on VSAT terminals and other things, but I think this is really a fleet owner operator challenge.
So in the Pacific region, again, there's a lot of water and not so much landmass. So the ability to focus your beams and get them where the people need them are critical. I believe there probably won't be too many more wide beam satellites developed for just about any areas, maybe for TV in Europe or something like that, but they aren't very practical in the Pacific, save for some just connectivity across vast ocean expanses. So the most recent satellite we had launched to the Pacific had a number of spot beams on that, primarily developed for aeromobile applications, but could easily be used to support specific islands. I believe there's other satellites out there already that have KA beams focused on specific islands to provide broadband connectivity to some of those islands, and that's the type of thing you would expect to see a lot of going forward on in the Pacific theater. Again, Quantum can do that as well and do it dynamically, but in the Pacific, you know where the locations are, you know where the people are, you know where the islands of service are, notwithstanding things like natural disasters where you may need some flexibility on steering those beams around. So I'm not sure if that fully answers your question, Nate, but that's what I believe the fleet operators are going to be needing to do to better serve the needs of the Pacific, at least the Pacific Islands and things like that. Pacific Rim area is covered pretty heavily already.
Yeah, it's the island areas. It always seems like you've got somebody looking for coverage like the Navy or NASA, or somebody in a region that's not well serviced, in a band that's not there, and the economics for putting up additional satellites over that area. And in my perspective, they're just not there in many regards, particularly for mobile water assets and those kinds of things. So I'll open it up to the other folks. Don't feel like you have to answer. Everybody has to.
No. I think, I mean, as an integrator, we look at that very closely. I mean, there's several things I could say to that. First is, the biggest challenge in the Asia Pacific region is just the scope of it. It's massive. And you mentioned, the blue water challenge. This is a huge challenge out in that region. And, it's one as an integrator we're very concerned with, because, we have interest in providing, services to the Navy, to the Coast Guard. And in so doing, you have to figure out how to fight those challenges and overcome them. One of the big ones we see right now is what we refer internally to the 5G challenge. You've got the FCC's recent order to move SATCOM out of the 3.7 to 4.0 gigahertz range. So that's just in the continental United States for now, but I think it's going to put a lot of pressure on the C-band market, and that's what you want to be using over the areas like the Pacific. So we're going to see how that all shakes out. But I think we all, both fleet owners and integrators, face a big challenge to provide services out there, not just to the outlying islands, but also to the blue water fleets, which I think if you read the news, we're spending a lot more time over there as a Navy.
Right. All right.
Yeah, Nate, if I were just add to that, I'll go back to a little bit of my comments on when I was, again, working kind of digital divide activities in the US. And the way that we were able to solve some of that challenge in Virginia was specifically working kind of on the back of government. So put together a program where the government programs were kind of a funding source to start that, but then my company brought a lot of investment into that along with them so that we could service across the board. And that's kind of what I see kind of happening, use government programs as a funding catalyst to drive capabilities in places where on its surface there is no economy of scale or business value program that would make it, yes, I'm going to go invest a whole bunch of capital to go do this and make it operate just for this thing. But if you can find ways to bring together government and commercial needs together, I think that's a way that you can, especially in the Asia-Pac region, help support kind of increased capabilities and capacity.
Okay, thanks, Mike. As you guys can probably hear my dogs tuning up again. I'll start with you on this one, Mike. Are there any current operational business platform systems out there that are capable of sort of managing multiple customers across satellite, ground, and all that together?
Yes. So, after decades of refining network management, service management, business support software for wired and wireless industries, I think there's several mature software platforms built on open standards that can be utilized for telecom and SATCOM operators and business support. In fact, there's a growing trend in the SATCOM community to adopt many of the established standards from terrestrial networking communities. As an example, one of the large government organizations is now supporting 3GPP, third generation partnership project, right? And standards there as an alternate to just straight SATCOM standard forums that were previously supported.
Thanks, Mike. Gus or Dave, did you want to address that question?
Sure, I
know Gus,
I could jump in there, Nate. Yeah, echoing and seconding Mike's comments, I think the technology is really maturing. We work a lot with people, organizations, companies that provide EMC. We work a lot with our government customers because obviously, they want us to be able to provide those sorts of services. I mean, at the risk, I guess, Kratos has got a great technology out there. I think they call theirs just Kratos NMS. MaxView is another one I jotted down here. I think DataPath offers MaxView. Hughes has got a great NMS. So, there are companies that have really invested a lot of money and time in doing this. And I think that technology is there and it just keeps getting better. And as an integrator, we're always interested in working with those guys. I also think, we're working very closely with the LEO operators. And I think, this is really critical to them just because of, the nature of the LEO constellations being so large and moving so quickly. They really need good NMS. And I think they're working very hard in developing their own internal tools, which will help that. And actually, DRS has taken a small step into that field. We're not an EMS, EMC provider, but our ICT portal is being built by software engineers that help link up with these management and control tools.
Okay, thanks. Sort of as a continuing thread, you mentioned during your talk about end-to-end, you talked about it being general, but I think both the sort of category SATCOM-as-a-service and managed services, you talked specifically to satellite and I assume that means some of the backhaul on the terrestrial, but from end to customer and stuff and managing across multiple platforms, because you mentioned that LEO, MEO, GEO, do you see any kind of convergence or platforms being able to do that entire spectrum, so to speak?
So I think if I understood the question, are we looking at the potential of converging LEO, MEO, and GEO into a single network, so to speak? And terrestrial, right? So you're looking for managed services across all that. Do you see anyone or anything out there that's getting close to that? Well, I mean, we have contracts today where we have both MEO and GEO on the same network, and it's not necessarily they're not talking directly to each other on their individual networks, but when it runs through the Global Network Operations Center, through a patch center somewhere, you get cross connection of essentially networks. If you're talking about like porting from LEO to MEO or MEO to GEO, I mean, I don't think that's going to happen anytime soon. I'd defer to David Baer to answer that question.
So, there are some
developments.
network. So I was muted again. So for the most part, Eutelsat is the network management systems we use are pretty specific for very localized applications. Like our broadband network is managing, hundreds of spot beams, but they're fixed and they're just managing data through those types of things. I think the things that Gus and Mike are talking about are exactly what folks like, again, mentioned at the workshop from Space and Missile Center, and also the Space Development Agency on the government side are really asking for these integrated systems. I don't know that anything really exists out there today, but there is the need and the demand to go have those systems do that. That said, there are satellites, low Earth orbit satellite fleets today that do inter-satellite links. I think Iridium's one of those that do it today. And there is a need, and there probably will be in the near future for some of those to do that from GEO to LEO. The only things I can think of today are optical links primarily. I guess there's RF links too from the TDRS satellites to the ISS, but there's also optical links from various satellites, including Eutelsats, that are now doing inter-satellite link capacity. But it's not truly a full management of LEO, MEO, GEO environments. And I think long-term, that is the type of thing that certainly the government is looking for when you look at some of these transport layers that the Space Development Agency is talking about. So I don't know of any products out there that do that today, though.
All right, thanks. So we've got a couple of minutes left. I'm going to throw one question, an additional question, and we touched on, or I think Mike did originally, about the ESA flat panels, which to me sort of the other end of the spectrum, right? The ground user, the Pacific Islander, somebody that's not very savvy. So obviously Starlink's, I believe their consumer terminals sort of an ESA thing. Do you see challenges in that space still for most technology-wise for that being able to be sort of a Swiss Army knife for a VSAT terminal? Is the technology there yet, I guess? And yeah, whoever wants to start, it doesn't have to be you, Dave.
I'll just jump in. So only because I actually just got off a discussion about ESAs with our chief technology officer this afternoon. I mean, will the technology be there? I mean, the technology's there. It's just not affordable right now. I mean, the OneWeb model is sell 1 billion terminals at Best Buy prices. I mean, that's how they're going to make their money. Right now they can't build an ESA that's be cheap enough to be sold at Best Buy prices. But I mean, they will be on the market, I would guess, within the next 3 to 5 years, maybe sooner. And they are a real game changer in terms of providing not only the ability to allow non-communications experts field antennas easily, but obviously the LEO market, I think, is really dependent on two things. One, David already mentioned ISLs, they got to work. And two, they're going to have an ESA antenna. The dual parabolic model, I don't think is sustainable, and especially if you want to support the DoD or US government. I think you're going to have to find an ESA antenna to do that. And it's got to be affordable and securable and pass our SRAT testing.
Agree. Anybody else?
I would just say, adding on to that, obviously companies like Kineta and SATCOM and others who are doing that, but for large scale operations, I came from a large, before I was a Paraton, I spent many years at Northrop Grumman. We spent a lot of time building ESAs for different environments and for different things. It's a very complex undertaking, and to get to the point where it's at a price point that is usable the way that we need for mass utilization for LEO constellations. It's going to take some time, but there's no doubt that eventually, like everything else in technology, it will hit a tipping point and provide availability. But when that knee in the curve is, I think that's still anybody's guess.
Thanks, Mike. Well, I think we've about run out of time. So I want to thank all the panelists. We've had some great discussion on a great topic. And for those attending PTC that will view this panel, thanks for attending PTC and supporting PTC. Mahalo and aloha to those of you. And thanks again to the panel. And we'll sign off. Thanks.
Thank you, Nate.
Thank you, guys.
Thanks.
Thank you, PTC.
Pleasure.